So again, what is a network? A computer network consists of communications media, like wires and wireless media, devices like computers and printers, and software needed to connect two or more computer systems or devices. Also, I should include in devices the communications devices like we just spoke of, routers and modems, and network interface cards also fall into that category. Computer networks can transmit and receive information to improve organizational effectiveness and efficiency. And this is where we come in, deciding on what would be the best setup for a particular network. Networks come in various types. We have a personal area network. Generally, this is what you would have in your home, where there is a kind of a short range communication between devices on the network. Local area networks are a little bit larger and can be used in offices or homes. They connect computer systems and devices within a little bit larger than 33 feet, but still in a small area. And generally this would be within a building or within a small grouping of buildings. Metropolitan area networks connect users and their devices in a geographical area that spans a campus or a city. And then a wide area network would connect a large geographic region. We're probably most familiar with the local area network, or LAN, where it would be set up as computers in an office or in a school lab or a group of labs or group of offices are connected to each other, and they can send and receive signals from each other and send and receive requests to devices like printers. There are three main approaches that can be used when a company sets up a network. One is centralized processing, where all the processing occurs at one location. Decentralized processing is basically centralized processing happening in multiple locations, where the individual locations have everything they need at their own location. With distributed processing, there are devices placed all over at remote locations, but they are connected via a network. So that is different from the decentralized processing. Those locations would not necessarily communicate with each other because they are individual processing locations themselves. Many networks are set up in a client-server approach. A client-server architecture is where you have multiple computers called clients that users are generally using, just users in the different locations, and they are requesting services from a server, and there are various servers set up to provide these services, and each server usually has one main job, such as a mail server or a print server or a server that manages the database. Networks generally have specialized operating systems that control the computer systems with the uniqueness of being on a network. And also there's software called network management software that generally monitors whether or not software is being used properly, keeps it from being copied, modified, or downloaded illegally, and it locates telecommunications errors and potential network problems. The internet is the network of networks. It's connected networks all over the world. And if you watch the lecture on how the internet works in this week's folder, you'll learn about the origins of the internet. ARPANET, which was a Defense Department project in the late 60s, is considered to be the birth of the internet, where 4 university computers were connected with redundant connections so that if any one of them was out of service, it could be bypassed and the other computers could still communicate with each other. Internet Protocol, or IP, and we generally hear the term IP address, it's the standard by which we identify computers on a network. And on the internet, they are the way we identify a computer on the internet. IP protocol is the set of rules used to pass packets from one host to another. An IP address is a number made of 64 bits that identifies the computer on the internet. A uniform resource locator is an address, and the book is referring to it as a web address, but it's really an internet address because there are URLs that are actually not on the web. But it's an address that specifies the exact location of a resource, and in the case of a web page, the exact location of that web page. This is figure 4.7 from page 174 on your book, and it shows a typical internet arrangement of computers. It's a very simplified arrangement, but in general we have multiple computers that connect to a router. The router understands all of the IP addresses of the computers that are connected to it, and it is possibly connected to other routers. And here we have two routers that are directly connected to networks. Those routers know all of the addresses on the computers that they're connected to, and so they are able to send messages and receive messages to those computers and for those computers. The Internet Corporation for Assigned Names and Numbers takes the responsibility of managing Internet protocol addresses and Internet domain names, and it has the authority to resolve domain name disputes. If you want to create a new domain name or establish your website on a particular domain name, you have to first establish that it is not being used, and this ICANN association can tell you whether or not you can have that particular domain name or not. Part of the URL is the top-level domain, and it categorizes a particular URL as either a commercial or business site with .com, an educational site .edu, a government site .gov, and so forth. Cloud computing is becoming very popular these days. It's a service by which you can store data and you can access software that's located on a device that is not on your physical premises, and they are offered as a service. It's very easy to custom make a package for an organization to, if they can determine how much space they need for storage and what software they need. It's a very big advantage to businesses in that they can save on hardware, storage space, and also probably get better prices on using software as opposed to purchasing licenses to run their own software.